Hi everyone, myself Dr. K. Assistant Professor in the Department of Civil Engineering, K.S.Rangasamy College of Technology, Trichango. Today we are going to discuss a very few fundamentals yet crucial topic in civil engineering, concrete making materials. This forms the backbone of construction and understanding these materials is essential for every civil engineers. Let's take a quick look at what we will cover today. We will begin with cement, its composition, properties, and hydration process. Then we will move on to the test on cement and in IS specifications. We will also discuss two important concepts: gel space ratio and Abraham's law. Now, next we look at the aggregate, the classification, Bureau of Indian Standard Test, and alkali aggregate reactions. Um, we also talk about water, the role and the quality requirement for concrete. And finally, we will brief touch upon admixtures and their effect. So let's get started. Overview of concrete making. Concrete is a composite material made up of four main components. First, cement, which is about 10 to 15% by volume. It acts as a binder. Then we have aggregate, which forms the bulk of concrete, about 60 to 75% by volume. They are inert filler materials like sand and gravels. Water, which is about 15 to 20% by volume, is essential for the chemical reactions for the cement for the workability. Um and lastly, admixtures, which are used in small quantities, less than 2% by weight of cement, to modify the properties of fresh or hardened concrete. So these four together make what we need for the concrete. Cement and chemical compositions and properties. Now let's dive deeper into cement. The most common type is Portland cement, which comes in various grades like OPC, 33 grade, 43, 53, and also types like PPC, Portland Pozzolana cement, and PSC cement, the Portland slag cement. Chemically, cement is composed of four major components known as box component, which is C3S. Tricalcium silicates gives yearly strength and generate heat. Next is C2S, or dicalcium silicate, contributes to later strength. C3A or tricalcium aluminates controls initial setting, but it is vulnerable to sulfate attack. C4AF, which means tetracalcium aluminoferrite, has a major role in strength and the effect of colors of cement. This typically compositions ranges from understanding this helps us to choose the right content for different applications. Um, Now, what are the key properties we look for in 3D concrete? Which is the first one is the fineness. Um, Fineness affects the rate of hydration. Finer cement's hydration faster. Soundness ensures that the cement does not expand excessively after setting, which can cause cracks. Setting time is crucial for workability. We have initially and final setting time. Compressive strength is tested at 3, 7, and 28 days, um, and it determines the grade of cement. Heat of hydrations. Uh, Heat of hydration is important, especially in mass concreting structures like dams, to avoid thermal cracking. And also, specific gravity is usually around 3.15. Um, the magic of concrete hardening happens through hydration. Um, so it is chemically reactions between cement compounds like water forming hydration products that binds the mix and develop strength. This reactions is exothermic, meaning it releases heat, especially in the first 24 to 72 hours. Hydration occurs in stages: initial reactions, dormant period, acceleration, and then deceleration. Factors like water cement ratio, temperature, fineness of cement, and admixtures affect hydration. The consequences are setting, strength development, heat evolution, and shrinkage. These are all the tests on cements to ensure uh, quality. We conduct various tests on cement. Um, Other important tests like specific gravity, heat, height of hydration, and chemical reactions. Now in India, we follow IS specifications for cement. For OPC, we have IS 269 for 33 grade, IS 8112 for 43 grade, and also IS 12269, which is for 53 grade. For PPC, it is 1488, and PSC it is IS 456. Um, they are also codes for special concreting like rapid hardening, low heat, and sulfate resistant cement. These codes ensures standardization and quality in construction. These are all the grades for various cements and PPCs. Portland cement slag contains 25 to 75% in the Portland slag cements, which plays the major roles. Um So gel space ratios and Abraham's laws. Now let's look at two important concepts in mixed designs. One is the gel space ratio and another one is the Abraham's law. The gel space ratio is the volume of hydration products divided by the two space available. A higher gel space ratio means denser concrete and higher strength. Abraham law states that the strength of concrete is inversely proportional to the water cement ratio. More water means more porous, which reduces the strength. These principles forms the basic of modern concepts mixed design such as IS 10262. Uh, Moving on the aggregate, they occupy 60 to 75% of the concrete volume. They are classified based on the size into fine and coarse aggregate. Based on origin, natural like river sand or M sand, which means manufactured like crushed stone. Based on shape, rounded, angular, flanky, etc. And based on density, lightweight, normal, or heavyweight aggregates are available. Uh, the shape and texture of the aggregate significantly affect workability and strength. Uh, our durability concern related to aggregate is alkali aggregate reactions, or shortly we call it as AR. And this is special reactions between alkalis from cement and reactive silica in aggregate. It forms a gel that swells in the presence of moisture, causing internal pressure, cracking, and deterioration. There are two main types: alkali silica reaction, which is common, and alkali carbonate reaction, which is rare. To prevent AAR, we use low alkali cement, non-reactive aggregates of minerals, admixtures like cements. Quality in water for use in concrete. Water is not just a mixing ingredient, it plays a critical role in hydration and workability. A general rule in water should be potable, fit for drinking. We conduct a test for pH, chloride, sulfate, and also compare setting time and strength and distilled water. As per IS 456, pH should be between 6 to 8.5. Chloride should be limited, especially to reinforced or pre-stressed concrete. Um, Chlorides, which affects the corrosion of reinforcement, sulfate, formation of expansion and crackings, sugar, oil, acid, retards and accelerate settings. A sewage industrial effluent may contain harmful chemicals. Sea waters contains high chloride and sulfate. Not recommended is except in special cases with precautions. So thank you. To summarize, concrete is a carefully engineering material made in cement, aggregate, and water on the admixture. Each component plays a specific role, and its quality directly affecting the strength, durability, and performance in concrete. I hope this session gave you a clear understanding of concrete making materials. Thank you for your attention. Keep growing, keep learning. Thank you.